Welcome members. In this lesson today I'm going to see how do we integrate such functions where if r f of x is a linear function x plus b, when now we're integrating this when it's in the denominator. Now, don't forget to subscribe to the channel. Now, the idea is simple. If you integrate this in the denominator, all you do is you differentiate this function and then you get this reciprocal. So 1 over the derivative of this, then natural log of that original function. But please be careful when you reach these two numbers, the last two. Be careful, we shall see. Now, you see now if the examples integrate the following, I have this one. So that now if I compare so that my f of x is 2x plus 1. We saw how to differentiate this, so I need the derivative. So the derivative of this is f prime of x becomes 2. Now meaning the integral of this will be to say it's 1 over the derivative. Its derivative is 2. Then natural log of 2x, the function itself. The function itself is this 2x plus 1. If I had say integrate the x, 2 plus 3x, still see from here my f of x will be 2 plus 3x. When I differentiate this, I have this as 3. So now if you compare these two, now my f of x is this. So this will be 1 over the derivative of this function. When I differentiate this, I get 3. Then natural log of the function. The function was 2 plus 3x. Of course, plus a constant of integration. Why? Because we don't have limits. It's like this one also is an indefinite integral, we don't have limits. So now this will be that my f of x is this. So my f of x is 4 minus 3x. When I differentiate this, when you differentiate the 4, we get 0. When you differentiate this, we get negative 3. So using this, so this will be 1 over negative 3. Then natural log of this function 4 minus 3x plus c, which will be, you take this one up. The idea is very easy. From here, all is you look here. When you differentiate this function, you get to 1 over 2, then natural log of this. Let us apply that and we see. When you differentiate this, we get, when you differentiate the order of this function, we get this as a 0. When you differentiate this 4x, we get 4. So it's going to be 1 over 4, then natural log of the function itself, which is 4x plus 1. Or if this is hard, you go through this process. But this one is a definite integral because it has limits, so we are evaluating it from 0 to 1, which will be now a quarter into natural log. Where there is x, we put 1. So 4 into 1 plus 1. Then minus natural log. Now we substitute the lower limit, which will be 4 into where there is x, we put the lower limit to 0 plus 1. So this will be a quarter. Natural log of, in the bracket, this will be 4 plus 1, which is 5, minus natural log of 0 plus 1, which is 1. A natural log of 1 is 0, and then we have 1 over 4, natural log of 5. You can leave it there, or you can press it in the calculator, and you give it to 4 decimal places. So if I give this 4 decimal places, I have 0.40 to 4. These are 4 decimal places. Now when I come to this, that our function with our f of x is this. When I differentiate this, I get 1. So which is 1 over 1. Then natural log of that function. It's definite from 1 to 3. Which will be now natural log of x from 1 to 3. Which will be, we substitute the upper limit first. So natural log of 3 minus natural log of, when I put 1, I have this. Natural log of 1 is 0, so this is natural log of 3. You can leave it there. Now, this one will be extra careful. So our f of x is this. So 1 over the derivative of this. When we differentiate this, we get negative 5. Or you can go through the process. But with ease, you can do it in one step. This is our function f of x. When you differentiate this, you get negative 5. So 1 over negative 5. 1 over the derivative of this function. Then natural log of that function, which is 1 minus 5x. This one is a definite integral, so from 1 to 2. In evaluating it, you see that this one will be negative 1 over 5, then natural of 1 minus 5x from 1 to 2. Now here is where I need the extra attention. Now, when you put here a negative and then a 2, the result is going to be negative, but there is no logarithm with a negative exponent. So all you do, you introduce moduli signs. So this will be now negative 1 over 5 into natural log. Now modulus, when you put here, we have 1 minus 5 into 2. Then modulus, then minus, when you put in the lower limit, which is natural of modulus 1 minus 5 into 1. Where there is x, where we put the lower integral and the upper limit and the lower limit. Now, we do this because you see the result here is going to be a negative. So this will be negative 1 over 5, natural log of modulus negative 9, because this is 10 minus 1, which is 9, minus natural log of modulus, this will be 5 minus 1, which will be negative 4. So always when we start, the result is going to be negative, we introduce moduli signs. So this will be now negative 1 over 5, then natural log of this is 9. Now modulus of negative 9 is 9, modulus of negative 4 is 4. Then if we apply our properties of logarithms, if you are subtracting numbers, the same as dividing. So natural log of 9 over 4. So you can press this on the calculator and you give it 2 for decimal places. Now, when I come to this, let me write it here down. It was integral from negative 1 to 1. Now the t over t minus 1 to b. Now from here, you see that if this is the function now, I need now f prime of t. When I differentiate this, I get 1. So 1 over 1. Then natural log of t minus 1. But we have from negative 1 to 1. This will be now natural log of, when I put in the upper limit, you put in the upper limit. Allow me to change the upper limit to be at 2 so that we simplify life. Let me change this upper limit to be at 2. So when I put in a 2, I'll be adding 2 minus 1. Then minus natural when you substitute the lower limit. The lower limit is negative, so I will be negative 1 minus 1. So this will be natural of 1. So here I don't introduce modulus because this one is already positive. 2 minus 1 is a positive. So 1 minus, now here I'm going to introduce the modulus, so natural of modulus of negative 2. Because the result is negative 2, we introduce the modulus. Natural log of 1 is 0, so minus, we have now minus natural log. Modulus of negative 2 is now a positive 2. And you can evaluate it for decimal places, or you can leave it there. So please don't forget to subscribe to the channel. I wish you the best. Let us see. We have more lessons about integration. I'm going to send more videos.